Welcome back, class. This is your Catia mentor, and today we're going to have a quick video on how to use the Sheetmetal app. So let's go to the Sheetmetal app, Sheetmetal Design. Okay, we're going to start by first setting up our parameters. When working with Sheetmetal, you want to pick your material thickness, and also your bend radii. So let me go to parameters here. Now, typically, if I'm at work, this would be linked to an Excel spreadsheet with different types of, usually aluminum alloys. You can also go with steel. And we would pick out from the Excel spreadsheet the material we're using. Let's say I'm using aluminum 6061 T6 aluminum alloy. And I'm going to use a thickness of, let's say, 0.063. And for my bend radii, let me look it up real quick. So if we're using 6061 T6, for example, aluminum, and we're going to go with a material thickness of 0.063. The minimum bend radius is 0.16. So bend radii, 0.16 radius. And as I click away, you can see the K factor. The K factor is based off of the material you are using, the thickness of the material, the bend radii, and also the angle. So if I was to go back and change, let's say, the bend radius to 0.3, watch how the K factor will update. So let's say we go with 0.30 bend radius and click away. Notice your K factor changes. As we tighten up our bend radius to 0.16, the minimum bend radius, click away. Notice how we get further away from the halfway point of 0.50. And for metals, your K factor will always be under 0.50. All right, so I'll come back and explain the K factor. For those of you that are not familiar with it, I'll wait towards the end of the video. All right, so once we have our thickness, our bend radius, and Catia calculates our K factor, hit OK. You can always go back and change it by double clicking. All right, so let's start by inserting a geometric set. Okay, geometric set. Okay, so I'll place my points, planes, any surfaces, sketches, I'll put it in the geo set. Anything involving solids or remover of solids, I'll put it in the part body. All right, so let's go ahead and start with a simple sketch. So I'm going to pick the XY plane, create a sketch. And let's do a very simple shape. And I'm going to go ahead and make this symmetrical. Hold on to the control key. Symmetrical, there it is. I'll make this line symmetrical to this one. Hold on to the control key. Pick the vertical axis. Actually, it should be this way. And give it a symmetry constraint. And I'm going to give this an angle of, let's give it an angle of 45. Or you know what, we'll just give it a distance. Hold on to the control key. And I'll give it an overall length. And I'll give it the same length for the height. Okay, so here we have our sketch, our web. Let's go ahead and exit. Okay, so we have our sketch. I have it in geometric set. And now we're going to create our wall, I should say. Okay, so this is our starting point for the solid. So once I click on it, it's going to say, hey, warning, we're going to put the solid in the part body. So you'll see it populate in the part body here. And say yes, we accept that. And you can see here it's starting to create our wall. And we'll use our first sketch. And okay, so notice I didn't type in a thickness. That's because it's already in the sheet metal parameters. Thickness is 0.063. All right, so let's go ahead and throw in some flanges. So let's start with wall on edge. But before I do, I'm going to place some planes. Let's say I didn't want a flange going up for the entire edge. Let's just say I wanted only a portion of the edge to be used. So I'm going to go ahead and insert some planes to limit the length of it. So I'm going to right click on the geoset, define. I'm going to offset some planes from this vertical plane. Move it over. And let's say I wanted to offset from this vertical, let's say 1 inch. And I'll do the same thing for the opposite side, create another plane. I'm going to reverse it and move it over to the edge, just so it's easier to find later on when I need them. Okay, I'm going to go ahead and give the planes a different color. I'm going to hold on to the control key, select both, right click, properties, and let's give it a color other than the default, just so they stand out. Okay, so there's my two planes. Okay, so I'm going to go ahead and create wall on edge. Okay, so I'm going to click on it. And once again, I get that warning saying, hey, you're creating a solid. We're going to place it in the part body. And I say, yes, I do want that. As you can see, it's underneath the part body in the tree. All right, so I'm going to pick this edge. Notice I picked the edge here, and the fillet goes inward. Now the thickness is 0.63, so notice how it's going 0.63 outward. If you want it to go inward, you can just flip this arrow. See, it goes inward. So the thickness is 0.63 off of this edge, 0.63 inward. If I flip the arrow, it'll go 0.063 in the opposite direction. So 0.063 is our thickness. And let's say for the length, we give it a length of, let's say 3. Preview. There it is. All right, so now let's say we wanted to limit the length of our flange. So I'm going to go over to limiting geometry. And for my first limit, my right limit, so here's right. I can pick a plane, or I can even use the arrows if I want. I'm just going to go ahead, instead of giving it a dimension, I'm going to go ahead and pick a plane. Notice it's going 1 inch off of the plane. I'll just say 0 distance from our plane. Preview, there it is. And for our second, the left one, should have done the left one first. Here's the left limit, left side. I'll pick the plane. There it is. Hit preview. And there's our flange. And OK. Notice there's no gap on either side. If you want to place a relief cut, we can go back. I'm going to zoom in a little bit so you can see it as we hit preview. So I'm going to double click on our wall, on our flange, and I'm going to go over to bend parameters, and I'm going to put a relief. Let's take a look at what a square relief looks like. Let me hit preview. So there we have a gap now. And typically we wanted round. So let's go to round relief, preview. There it is. And let's do the same thing for the opposite side. Okay, so for the right extremity, let's go to also round relief. And you have all these other options you can play with. Let's take a preview at some of the other ones. Zoom out a little bit. Let's take a look at tangent. Gives us a preview. See that? Let's go with linear. Gives you a preview. And let's go with maximum. Okay, so it gives you the full fillet. I'm just going to go with round relief like the other one. And preview. And there's our relief. And OK. Okay, so once again, going back, notice how we created the fillet inside our wall, our horizontal wall. We're going to do a different one later on. All right, so let's create two more flanges, but this time we're going to make the flanges go down. Let's say we had to make flanges go, we had to make them go downward for these two edges. So let's go ahead and create the wall flange, picking this edge. And let's say I want this surface to be coplanar to this one, so I'm going to move the thickness inward. Now these two walls are coplanar. And in this case, we don't need any reliefs. So let's hit OK. All right, let's go to the other side. Let's do the same thing. Another flange. And we want the thickness going inward. So it's coplanar to the other two. So all three are coplanar. All three flanges. And all right. Okay, so now let's do a different type of flange. Okay, so let's go to this one. So we've been using wall on edge. Let's go to flange command, flange. Notice that the fillet is on the exterior side of the horizontal wall. The first three we created were on the inside. This time it goes off at a tangent from the edge. And let's give this one a length of, let's say, 2. Preview. There it is. Also, I forgot to mention on the previous 3 walls we created, it can measure from the inside. It's a little hard to see. From the actual, I should say, tangent of the fillet. I know it's hard to see. So it would be measuring from the tangent here. So that's our standard. If we were to say, hey, we want to measure from the wall, from the bottom of the wall, we can go to this one. Oh, misclick. From the inner length. Notice now it's measuring from here to here, distance of 2 inches, versus from the tangent, right, to here was 2 inches, right? and preview. There it is. Okay, so there's different options you can work with here. You can also pick from the outer side of the horizontal wall. Okay, I'll leave that up to you. All right, so let's go ahead and hit OK. And let's go ahead and unfold just to get a preview of what we have so far. So we're going to unfold. Okay, so there's the flat pattern. All right, so let's say we had to go back and add some holes. I'm going to add holes to the flange here. Okay, so let's say we need to add a hole. So let me first take a measurement. 1.961. Okay, it's about 2 inches. All right, so let's say we had to place a hole from this edge 1 inch over and 1 inch from the base. So let's go to model, actually refine, go to hole command, but first I'm going to pick the edges to dimension from, hold on to the control key on the keyboard, and let's add a hole. And we can change our dimensions. Okay, so let's say we wanted to go 1 inch from the bottom. Okay, double click on this one, 1 inch from the edge, from the outer edge, and OK. And let's give it a diameter of, let's say 0.125. And depth, as long as it goes through the 0.63 thickness, we're good. And OK, there's our hole. Okay, let's repeat the same thing on the opposite side. I'm going to hold on to the control key while I pick my edges, let go of the control key, go to hole command. And once again, I'll use 1 inch for my dimensions. Double click, 1 inch from that edge, 1 inch from this edge, and I'll use 0.125 diameter. I should have more holes, but just to make this a quick video, I'm going to move on. All right, another thing you can also do is create holes in the flat patterns. So if I wanted to go to the flat pattern, you can add holes while it's in the flat pattern. So I'll do the exact same thing, except I'll do it on this flange. So let's do the same thing again. I'm going to hold on to the control key while I pick my edges, place a hole, and once again I'll use 1 inch for my distance. Okay, same for this one, 1 inch, and OK, and I'll leave it at 0.125 diameter, and all right. Okay, so you can always create the holes in the flat, or you can do it in the form position. All right, now I want to go over pocket, or I should say cutout. Okay, so let's say we wanted to make a cutout on this wall. Okay, I'll leave it in the formed position. So I'm going to first create a sketch. I'm going to define my geoset. Oh, it's already underlined, it's already defined. I'm going to create a sketch on the plane. And let's say we had to create some type of slot. And I'm not going to worry about the dimensions just to speed this up. Exit the sketch. All right, so now we can make a pocket. And it's telling me, hey, we're going to create the pocket in the part body. Yes. So anything involving solids or removing of solids, we need to do it in the part body. And OK. They're too close together, but I'll just leave it alone. All right, so let's say now we wanted to remove some of the material from the horizontal wall over to our flange. And let's say it's easier if we do it in the flat. So we can actually do pockets in the flat just like the hole command, or I should say cutouts, just like the hole command. All right, so I'm going to go over to the flat pattern, and I'm going to sketch on the XY plane. And let me place the sketch in the geoset define. There it is, it's underlined. So I'm going to place the sketch in the geoset. All right, so I'm going to use profile. And this sketch I'm creating, I'm going to use it to make our cutout. And obviously I'm just guesstimating. All right, and I'm going to go ahead and round off the corners. So I'm going to hold on to the control key. I'm going to round off not all the corners, but some of them. Holding on to the control key on the keyboard. Now I can let go, and I can add a fillet. And I'm going to give it a fillet of, let's say, 0.25 or 0.5. Enter. And they're all equal. So if I was to change one of them to, let's say, 0.375, 3/8 of an inch, they all change because they were created all at the same time and they have an equal constraint. As you can see, which you can always delete, by the way, if you wanted to. If you wanted to make a separate radius dimension for one of them, break from the others, you can always remove the equal constraint. Okay, for time I'm not going to constrain the sketch completely, so I'm going to go ahead and exit now. And I'm going to use the cutout. Let me first define my part body, right click define. So any creation of solids or removal of solids, we want to do it in the part body. So let's go ahead and create our cutout using our new sketch and preview. You can also change direction if you want. Preview. My mistake, I meant to say reverse preview. That's not what we want. Let's go back to where we were. Reverse preview. Okay, that's what we want right there. And okay. Okay, so the cool thing is you can do a cutout or a pocket in the flat pattern, and then we can go to the form position, and there it is. Okay, so this is fold, unfold. Now let's add a few fillets. Before I do, let me add a chamfer. Why? Just for fun. Add a chamfer. Let's add some fillets. Round off the edges. I'm going to hold on to the control key on the keyboard while I select my edges to fillet. And let's go ahead and fillet. And I'll go with 1/2 inch radius or 1/2 inch radii for all of them. Alright, so I can have my geo set now. Leave my part body on. And I can unfold, fold, right? Alright, now for those of you that don't understand what a K factor is, let me go over it real quick. But I'm done with modeling Catia. Alright, so K factor. What's a K factor? So first you would pick your material. So typically at work, we work with aluminum, 61 T6, 70, 75 T6, 70, 75 0 temper. So the temper tells you how this material, in this case an aluminum alloy, was treated. Was it heat treated? Was it annealed to give it strength, to improve on the properties of the material, for example? Alright, so earlier I said I use 063, 6061 aluminum, T6, and the minimum bend radii allowed is 0.16. If we go any smaller, so if we were to go back and use a smaller bend radius, there's a good chance that the material will start splitting, it'll start cracking. It will not be able to handle the small radius or the angle. So we've been doing bends at 90 degrees. If you wanted to do a bend at a different angle, let's go back. Flange. We can always change the angle if we want. Let's say we go with the closed angle. Let's say 100. Let's say 45 degrees. Preview. And OK. So the tighter the angle, so we have an inside angle. The tighter the angle, the smaller the bend radius, the more stress you place on the fibers here that are in tension and the ones that are here in compression. So as you're creating, if you're using a brake press or maybe you're using a tool to hydroform it to give it this bend radius, the fibers on the outside are feeling a lot of tension. The ones here on the inside bend are feeling compression. Okay, so let's talk about K factor. Okay, so our K factor is based on the location of the neutral axis. So let's say you're dealing with aluminum. Let's say we're dealing with 6061 T6. And just to make the math easier, let's say we have a thickness, sheet metal thickness of 1 inch. And let's say the distance from the inside, so here's our inside bend radius. From the inside to this neutral axis, let's say it's a distance of 0.45 inches. It's always under 0.50. Okay, 0.50 is the halfway point. If your K factor is 0.50, that's the halfway point. It's always going to be lower. So let's say our distance from the inside to the neutral axis is 0.45, let's say. So we're going to take 0.45 divided by the thickness, which is 1 inch. So 0.45 divided by 1 gives us a K factor of 0.45. Okay, so K factor will be 0.45. K factor is always, if you're dealing with metals, most materials, it will be less than 0.50. So the neutral axis is always inward on the compression side. Now at the neutral axis, the fibers, they don't feel anything. I mean, unless you're putting a force going in the same direction as the arrows, okay, if you're pushing on it like compression, you'll feel the force. But if you're doing a bend radius, Your neutral axis will not change in length. Now, as you go inward, the fibers feel more and more compression, so you're crushing the fibers inward towards each other. Okay, so they feel compression, and the further you go out to the edge, this is where you get the most compression. Now, if you go outward from the neutral axis, these fibers here are feeling a lot of tension, and as you move to the edge or as you go outward, these fibers feel even more tension. So these are being elongated. Okay, they're being stretched, while the inside are being crushed, they're being compressed. All right, so that's our K factor. So what's a typical K factor? So if your bend angle is around 90 degrees and you're using the minimum allowable bend radius for that material, whether it's aluminum, steel, copper, etc., our K factor for soft brass and copper is around 0.35. Aluminum, copper, brass, mild steel 0.41. And here we have other materials at 0.45. So once again, typically at work, when I'm ready to create a piece of sheet metal from scratch, I will go to my parameters, and then I'll link it to an Excel spreadsheet where I'll pick my material. Let's say aluminum 6061 T6. I'll pick my thickness 0.063 for example, and that's in inches. And the table will automatically pick the smallest bend radius allowed. Alright, so I hope you liked this video and see you in the next one.